Okay, some of you asked for a U-substitution review, so I wanted to start with a problem that was easily recognizable as U-substitution. And that is because you can see the derivative of x cubed is something x squared, and the x squared is in the problem. And you can see that's going to be U-sub just by that relationship. So, the first thing you do is pick a good U, and most of you know by now that the x cubed would be U. So u would be x cubed. You take the derivative, so du dx would be 3x squared. Since it's just x squared, I need to get rid of the 3. I need to divide and make that 1/3. And I need to multiply by my dx. So 1/3 du equals x squared dx. X squared dx is right here. So take that out and put in 1/3 du, and the du needs to go at the back for notational reasons. Then you had the sign and what you chose as your u, so this is now sine u. From there, you know your antiderivative of sine is negative cosine. So you can bring down the 1/3 and make it negative to do that antiderivative. And your final step needs to be to substitute back in. So negative 1/3 cosine u would be cosine x cubed, and plus c. Don't forget your plus c. Now, over here, I have the same problem, but I have a definite integral. I have the limits going from 0 to the cube root of pi. And what changes there, you do this work the same way, except when you get to this step where you have your u in there, you need your limits to match your variable. Up here, your variable is x, you have a dx. Here, your variable is u, you have a du. Your limits need to be u limits. Since u is x cubed, you're going to plug the 0 in. So this bottom u is going to be 0 cubed, which is still 0. And the top one, the cube root of x cubed, the cube and the cube root would cancel, or excuse me, the cube root of pi cubed. The cube root and the cube would cancel, and you would get a unit of pi at the top. And that just came from plugging these two limits in to this equation that you made. You get these new limits when you take the antiderivative and get the negative 1/3 cosine u. You're going to evaluate it from the new u limits if you have u, or if you resubstitute and put your x back in, you need to go back to your x limits. You're going to get the same answer either way. I prefer this way because it just seems like less work. So I'm going to finish this one out. So that will be negative 1/3 cosine of pi minus negative 1/3 cosine of 0. And from your unit circle, you remember that the cosine of pi is negative 1. So I have negative 1/3 times negative 1. And I'm going to make that plus a positive. The cosine of 0 would be a positive 1 from your unit circle. So I have two negatives here that make a positive 1/3. And 1/3 times 1 is a positive 1/3. So my overall answer is 2/3. If you do the work over here, you're going to get the exact same answer. You're going to get the exact same math at some point. It's just how you plug in. Okay, I have two more examples here where I am using U-substitution. This first one actually does not have to be U-substitution. You could write this 4x minus 1 3 times and multiply it out, or use Pascal's triangle to get a polynomial and just use your power rules. But you can use a U-sub, and that might be an easier solve for some of you. If I was doing this as a U-sub, I would choose my u to be 4x minus 1. I want to add that 1 with it because it's going to go away when I take the derivative. So I take the derivative of u, du dx. Derivative of 4x minus 1 is 4. And I need to divide by 4 and multiply by dx because there's not a 4 in the problem. So I'm going to have 1/4 du equals dx. And I'm going to replace the dx with 1/4 du. I'm going to put the 1/4 out front because it's a plain number, and my du in the back because that's where it goes notationally. Here, this is what I chose as my u, so now this is u cubed, and it's a power rule by itself. So I'm going to bring down the 1/4. I'm going to take the antiderivative of u cubed, so I'm going to add 1 to the power and get 4. I'm going to divide by that in front and get 1/4. Don't forget your plus c. I always just like to add that in. And then I can multiply my 2 1/4 and get 1/16. I can plug back in for u and put it to the 4th power and put my plus c. So that can be done as a u substitution. If you Pascal's triangle or multiplied all that out and got a polynomial, it would be the same as if you had gotten a polynomial and done the power rule in the first place. Number 4 is another example of where a u substitution is helpful. You know that there's a rule for secant squared because the derivative of tangent is secant squared. But this is not just a plain x, this has a 6 with it. So some of you can do this in your head. This is like that first day when I was asking you if you can do any of this in your head. If you can't, then you do a u sub with the 6x. Then your derivative would be 6. You want to divide by the 6 because there's no extra 6 in the problem. You want to multiply by the dx. So 1/6 du is going to be dx. I'm going to replace that dx with 1/6 du. And then this is where I chose my u, so I'm going to have secant squared of u. And now I'm to something I know the rule for. And since the derivative of tangent is secant squared, the antiderivative of secant squared is tangent. So bring down my 1/6. I have tangent u plus c, and then I can plug back in. So this is 1/6 tangent 6x plus c. And again, this is one that some of you might be able to do in your head, but if you can't, u sub will work. Okay, so I have 2 more u substitution problems. The first one, I wanted to bring this up because some of you might be thrown off by the 3 or the 5, something like that. But your u, the best choice for your u is the whole denominator, which would be 2t plus 5. And you can take that 3 and move it out front, and it's not a problem anymore. Just leave a 1 on top. So here, when we do du dt, you get 2. Divide by the 2. So you get 1/2 du equals dt. And when I bring that 1/2 out front, and I should have had a t here. Sorry, in the original problem. When I bring that 1/2 out front and the 3 is there, I can just write it as 3/2. That left me with a 1 because I moved the 3. The bottom is now my u, and again I have my du at the back. So this becomes the new u variable problem. You should know this is 1 over u is the derivative of natural log, so we're going to bring down the 3/2, and the antiderivative of this will be the natural log of the absolute value of u. And so I have 3/2 natural log, plug back in, absolute value of 2t plus 5 plus c. And if you're in a situation where you are doing a differential equation or something like that, and you know that the t's that you're going to be using for that problem are going to be positive, if it was talking about time, you would know it would always be positive. And in that case, you could drop the absolute value. So that occasionally will happen on the exam. You can look for that. But for here, I'm going to leave it in absolute value. If this were a multiple choice question, I would be looking for the absolute value. This problem is your classic u sub. You're looking at e to the x to the 4th. So that is a power on x. I just didn't have another way of typing it on here. And the derivative of that is going to be something x cubed, and you have an x cubed in the problem. So you make a good choice for u when you say x to the 4th is going to be your u. Now, when you take that derivative, du dx is going to be 4x cubed. And you're like, okay, I have 5x cubed in the problem. It's the same type of situation that I had over here. I can take the 5 out front. I'm going to need to divide by the 4 here because I don't have a 4 in the problem. And multiply by my dx. Now, I do have x cubed and dx in the problem. I'm going to move the 5 out front, and I have to have this 1/4 du put in. So the 5 that's out front and the 1/4 here will go to 5/4. This and this will go away and be replaced by the du, since I've already got the 4th in there. And I'll just have e to the u. And this one's an easy one because the antiderivative of e to the u is e to the u. So bring down my 5/4, have e to the u plus c, and plug back in. I will do another video on u sub back sub when I have time.